This is Marcus's test drive of the talk that he's going to be giving at, what is it, Scala Days?
Yeah, it's the workshop.
Right.
Workshop, yeah.
And I'm really glad that Marcus agreed to do this. We are always open for people to test drive their presentations because we are always at a dearth of speakers. So please feel free to do that in the future. We are, for those who are out in, not actually here, land, we're at Kismet Co-working Space, and I would like Josh here from Kismet to just give us the brief pitch of Kismet so that, because they're gracious enough at the last minute to get us in here.
Thank you, Brian. We're really glad to have this phase group here today, and we're excited, about the possibilities of bringing in even more tech and developing groups. And yeah, this is our second location. We just opened in March. We have another location in Chestnut Hill, and we're working on a third in Manayunk. Right now, we're located just south of Spring Garden Street in Philadelphia, PA. And we've got private offices, floating desk, conference rooms, anything you need to have a good office experience. So yeah, look us up, and we hope that this is one of many events like this. Thanks again, FACE.
And the link to the Kismet website is in the meetup and will remain in the meetup for anybody who wants to check it out. And finally, one of the participants out there is Peter, and I'm not going to try to pronounce Peter's last name. He told me not to try. But Peter offered to reimburse me for the food this evening. In fact, pretty much insisted as his way of contributing after Michael Pilquist's awesome talk a few weeks ago. So number one, thank you, Peter. And number two, that sets the bar a little high for tonight, I think. And without further ado, then I'm going to kick it over to Marcus. I will, if this recording is not terrible, I will post this on YouTube and post a link to scalaface.org sometime later in the week.
Awesome. All right. So halfway to stupid. All right. So what would be better? Would it be better to do this kind of like a workshop, and I'll talk for a little bit, maybe teach something, and then like do exercises, or would it be better to do like a live coding thing, or what do you guys like think would be easier to do here? Because it is written as like, I did write it as a workshop, but we can do it like a talk or live coding session or something.
I think use it for your purpose, which is the practice your workshop.
Like the workshop type thing? Yeah. All right, awesome. So we're gonna try to work through some stuff. So I wrote it all in a tool called Toot, which is a tutorial generator for Scala. It actually compiles your, it kind of compiles. It runs your code in the REPL, and that output gets generated as Markdown. So that's how it's written. So everything that we'll see does actually compile in the Scala compiler. So I think this is one. So okay, right? Yeah, I know this is happening. All right. So the point of this, the point of type-driven development, is to get as much as possible into the type system, essentially. Right? It's a way of writing programs such that your types can fully define your program. Right? This is a very lofty goal, right? And it may actually be very close to, if not impossible, to do fully. Because you have to, at some point, deal with the user or the database or something, right? So you eventually have to do something impure. But we can do as much as we can, right? So let's see what that kind of looks like with a simple example. Right? We're going to go with a zipper, right? Is everyone familiar with how zip works? You take two of a collection and you put them together. Now you have a single collection with tuples inside of it. Right? All right. So a simple way of doing this is to just write a function, right? We have two lists, and then we want a single list with a tuple inside it, right? There's this nifty function here called zip. We can do with lists, right? And then we can just kind of call our zip function and get our new list out. This is, the simple way of doing it. And then, so like we can do this ad nauseam. So we can write it a different way, right? So this kind of flips them, right? And then it's called the same way as the previous one, right? So this is a problem for someone who likes type-driven development, right? We wrote two functions that have the same type signature, but they have wildly different results, right? The input types, the output types are identical, but they're different. So the compiler cannot help you here, right? And that's a problem. So the methodology here that Edwin Brady has is 3 words. You type, you define, you refine.
Who?
Sorry, Edwin Brady. He wrote type-driven development and
Okay.
Yeah, so he is like the type-driven development guy.
Okay.
Kind of, yeah. So okay, so so he says type, define, refine. So this is just going to be repeatedly refining, and refactoring, and refining. Okay. So what we need to do is find a way to put that into our type system, right? Take away the ability to kind of flip things around. So we can do that by parametrizing our types, right? So proper types can be lifted out of functions as simple type parameters. Does everybody know what a proper type is? Awesome.
I don't know what a proper type is.
So a proper type is a type that can be that has values, right? So proper types are like int, string, list of int, right? List is not a proper type.
So anything that has a generic on it is not a proper type?
Yeah. So because it's not there are no values of that type, right? It has to be a list of something. So when we have proper types, we can lift them out as type parameters. And that's what we do here, right? So we can define this function again, right? A and B, and it compiles, right? If we flip them around, it will not compile. So, now through this refinement, right? Not only have we made it impossible to call improperly, we got rid of the wrong method entirely. It will not even compile. Like it doesn't exist in the world of type-driven development, right? So this is a simple example of how this can help you write correct programs, right? Because that's the goal at the end of the day. Like we're all sitting in front of machines, destroying our eyes, typing away, getting carpal tunnel to create correct programs, right? There's no other reason. And this helps us. So really what we're doing is we're using the compiler as an assistant, right? So a lot of the times, especially people who come from untyped language backgrounds, they see the compiler as like this adversary that they have to satisfy, right? And a lot of typed languages kind of use it that way. You know, like in Java, you're constantly trying to fight it to get it to do the things that you're like, this is mathematically sound. Why won't you compile, right? So that's why compilers get a bad rap in certain circles, right? But here we have a type system that's powerful enough to allow us to do things that are mathematically sound. And that'll help us along the way, right? So that's what we're trying to do. All right. So, yeah. So if we were to write the swap zip, right, we have to change the left-hand side as well, right? So here we have to change here, right, the beginning, right? And then we can write it this way. And if we write it A zip B, this would not be possible, right? So the type signature here absolutely defines what the function does. Right? All right, awesome.
So I feel like there's an insight here that I'm missing, right? Because it's funny, I remember actually when I was looking at Slick, literally at the more abstract levels, instead of doing string, he was defining his own types called code.
Yeah.
Like what is the reasoning about what data you will actually pull into generics or the type annotations or whatnot? Like what's the thinking behind, like, do I pull out B or A versus do I pull out the whole list? Like,
So this is this is what I mean. We're going to go through multiple steps of refinement. Okay. So we're going to start at the simplest thing. Simplest thing is, how do I get this function to not compile
right.
if I write the right side wrong?
Right.
The first right that I said was with the W, the second one was with not. So if I type it incorrectly, how will I get the compiler to help me, right? Because in the first version it wouldn't.
Okay.
So that's the first goal, right? How do I do that? And then we'll go through repeated refinements, and we'll do more and more and more, and the compiler will help us more and more. And we can build like entire applications at scale using this discipline, right? And it is a discipline. It's really hard to write programs this way. Really, really hard. You have to follow a very strict set of rules, and if you do, it will be great. And you can give libraries to people who have no idea how to deal with like a database, right? You can give entire libraries to people. They just have to use the library.
And then they will
don't
get
care.
obscure, unreadable compiler error messages
Yeah.
if they use the library wrong.
Yeah, exactly. But at least they know that they use the library wrong.
Right.
Right? Yeah. So, all right, yeah. So, there were some exercises, write a function that can zip 3 lists and write one that can zip 3 vectors, right? So the idea behind these exercises is just the duplication of code. All right, so do you want to do them or do you want to just like move on? Okay, awesome. Let's just move on. Great. All right, so all right, so zipping 3 lists looks like this. You just take 3 lists and then you have a nested tuple, right? And then you just kind of nest these calls. And doing 3 vectors is the same exact code, right? It's exactly the same. So, this is very wet, right?
What is wet?
Write everything twice.
Oh.
Yeah, so it's the opposite of dry, which is don't repeat yourself.
Would it be like when, write everything n times?
Yeah, but wet has that
Yeah.
sticky.
Yeah, it has that feeling of,
Okay.
That's why it says either way.
It's like my lawn.
Yeah, exactly. It's like a lawn. So good. So here, the only difference here is that we have a list or a vector. So we have to abstract the container somehow, some way, right? We have to do it, right? So
I'm going to interrupt you with a question. Peter gets his question to interrupt you because he paid for the food.
yeah. Anybody can interrupt me at any time.
Can we get a list of those rules?
A list of those rules? Yeah. That's actually a really good idea. And I'm going to make a note of doing it.
How did that happen? Yeah.
Yeah.
The mic. Okay,
There we go.
good. All right, sorry about that. More technical difficulties
Yeah,
here.
yeah, we don't know how to work buttons.
Marcus,
Make sure they can still
Marcus
hear us.
created a static electricity field or something that,
You're welcome. Yeah, so, but so a list of those those rules about the distance, that's a good idea.
so Peter, the answer to your,
Because I
so-
take notes on paper.
so
it takes
so
me
so
forever.
the answer to your question is yes, but maybe not right now.
Yeah, it's yes-ish. It sits inside of my head, and we'll get it in.
Yeah, that would be great.
Yeah. That is tidy.
I can imagine one of them is don't allow you to have same signature for different things.
Yeah, that's like the most important one. If you see the same signature twice, you're doing it wrong.
Or you haven't refined enough yet.
Yep. Yeah, you're on your way. All right. So yeah, we're abstracting the container. There we go. All right. So we have to redefine our zips, right? So we can have a general zip, right? Which takes two things and makes it one. And then we can make and we can make as many as we want, as big as we want, which just call the two, right?
So
So that's
can
how
you
it works.
take a second? I expect somebody in your workshop will ask this as well.
Yeah.
The syntax there, the generic type, F
Mhm.
sub underbar, I see that a lot, but can you give a succinct definition of that?
Yeah, so it's it's the type parameter of a container,
Any container.
any container.
Okay.
Anything that takes a type parameter, you can use for that, all right? So it's the type parameter for a type that's not a proper type, that takes a proper type.
So that would include any container type. It would include option,
Yeah,
which we model
option,
as a container
list,
type.
Vector, stream.
Yep.
Data set. Yeah.
So I had a suggestion I was going to give you, Dan, but since we're talking about, maybe I'll give it now, which is when you were talking about proper types, I think the good name to use is type constructors, which you can talk about as factories from types to proper types.
Yeah.
And if you say that, then you can do that's the shape of the type, the function, right? With one underscore means it takes one argument,
Yeah.
produces a proper type. Whereas
Yeah,
with that two,
yeah.
it would be a two argument function and so on.
Yeah. Yep.
Um,
So it's a type constructor. Yeah.
Since you mentioned data set, right?
Yeah.
You're gonna like implicit this out, right? And you're gonna do like a zip 3 of a data set that that's gonna come in like that. But then would that work with the encoders? Because
So
then,
there are fancy things you can do. So with data sets, there is extra plumbing, but like the general idea is the same, right? You just abstract until you're there. You just push more into the implicit
Okay,
scope.
that's-
You just
I'd like to
Yeah.
see that
yeah,
because I've tried to do that and haven't
very
succeeded.
very.
Okay.
And we get to similar things. All right, awesome.
So what that's saying, so that first signature there then is saying that zip is parameterized by some kind of container.
Mhm.
We use container rather than non-proper type
Yeah.
for clarity.
Yep.
It's parameterized by some kind of container of one type of thing,
Mhm.
and then two proper types.
Yes. Yep. And then we take these arguments, which is the container with the first proper type, the container with the second proper type. Then we produce a container with a tuple of those, right? So
And necessarily that container, they're the same container or a super type of that container.
they are the same.
They have to be the same. So
Because so the inputs are in contravariant position.
Right.
The output is in covariant position, so
Yeah.
they have to be, so it's invariant. C++ would
Yeah, I
tell you
don't,
that. Scala,
I don't, I don't want to jump the gun and talk about what's next there. This is,
so we have a problem, right? We don't know what to do with an F, right? So Runar Bjornsson had a great talk a few years ago about liberties constrain and constraints liberate, and this is what that talk was about, you know. So we liberated our types in this function, right? So it's not specifically a list, it's not specifically a vector, so it's liberated. So we've constrained our implementation, right? Because we don't know that it's a list, we can't just call zipline, right? Which is what we were doing before. So what do we do? All right. So the first thing we can do, because it's a Scala, and Scala allows you to do functional programming, is we can pass in a function, right? A function from f of a and f of b to f of a and b, right? So that's one way we can do it. But this is crazy, right? Like the type signature already is just foul, right? You don't want to do this, right? So another way to do this is to abstract the function out. And since we're doing type-driven development, we abstract the function out into a type, right? So how do we do that, right? We do this with a fancy thing called a type class. Type classes are simply functions at the type level, right? Okay, so this is saying that we have a function called zip, right? Given some f, we will get a zip function out, right? Given some f that is a type, we are guaranteed to have this function, right?
so in this case, and I'm sorry, I don't mean to keep interrupting,
Yeah.
but we have a homonym problem here. So the type class or the function on the type is the capital zip trait,
Yes.
okay?
Capital Z.
As distinct from the result of applying that capital zip, which returns you a function that happens to be called lowercase zip.
Yes.
Okay,
Yes. Yeah. So this is very common, where the capital and the lowercase, the capital is the type version of it, and the lowercase is the value version of it. In Scala, that's how it's done typically. You can name them the same thing, but that just gets silly and weird, and it's terrible. So don't do that.
but in effect, the fact that a type class in Scala is implemented as a trait is an artifact of the Scala language. It would be done
So-
differently in Haskell, for
Yeah,
instance.
so Haskell is purely functional. It doesn't do object orientation, so you can do different things with the type system there, because you can completely ignore, like variants in Haskell. They don't have that problem, whereas Scala does, because we have.
Because it's object
Yeah, and
oriented.
there's actually a compiler bug that's marked as won't fix that we run into when we do this type of stuff. But that's later. So a type class is essentially, we're saying this type f represents this value, right? Because functions in Scala are values, right? Represents this value, right? So type-driven development is all about types and values being indistinguishable. And that's how we do it with functions here, right? We do it with type classes. All right. So yeah, we use a trait for this, and then we can just pass the trait in, right? So this looks a lot better than passing in the function. And then we call the function on the trait for our zip function. Okay? Right. And then for the version of 3, we just nest it. Keep nesting stuff. That's how
Oh, wait,
Yeah.
okay. I was confused for a moment there, but what's happening here really is you have two different Fs.
Yeah.
Right.
So yeah, we're gonna.
And this
do
is
that.
also common?
Yeah. So it is very common to name the value parameter
The same thing,
as the
the
type.
type you're calling the function on.
Yeah. It's common.
Because why not make things harder to read?
Yeah. So there's a way. So there's a way out of this because we're doing type driven. There's a way to leave this behind. Right. And I think that comes like very soon. Your mouth.
Oh, well, I was going to say, it's pretty common, except if you have two type class instances for the same type parameter, then you can't do
That's
that because only one of them could be called F2
Yeah,
and
right.
all the other ones.
Right.
So you have F1,
Yeah.
F2 or something.
And what we're going to do gets rid of that problem. So okay. So yeah. All right. So there are two exercises which we write two type classes. One which is both A and B. One which is only A or only B. And this can be doing this can be done in many ways. I just do it in a very simple way because it's not super important. It's just to get the idea of type classes. Yeah, and they can be as complex as possible. All right, we're gonna go and do more. All right, so that was our topic. All right, so both A and B, is a type class that's parametrized with two types, and it just has a left and a right, and they're just A and B, right? And for the or, I just use option. Yeah. It's as simple as that. It can be as simple as that. Yeah. There are more complicated things you can do, of course, right? To guarantee, to give like certain guarantees and all that. But yeah. So type classes bind types to values.
So what's the intended use of these two type classes?
Just to have, so tuple 2 is a type class,
Okay,
right? It's just like and here, right? So the purpose of and is the exact same purpose of tuple 2. To
okay,
take two things and pass them around as one.
okay.
It's to be both, right? And we call that a product.
And what about or?
Or is to be one or the other.
But there's no way that the compiler can protect you from having both of those options defined,
Yeah.
given this
yeah.
current definition,
Yeah, given
correct?
this definition.
So that would make that in your way of refining, we're not there yet. with
Yeah,
or.
we're not there yet. Yeah,
Okay.
This would be like. the
Just trying to
first
clarify
step,
my own
And then
understanding.
we would refine.
Right. Okay.
Yep, absolutely. Yep. All right. So now we're going to talk about implicits, right? This is like super useful and confusing at the same time. But it's how Scala does, quote unquote, like real functional programming. And what separates Scala as a functional programming language from things like Haskell is that in Scala, the implicits are explicit, right? Whereas in like Haskell, implicits are implicit, right? So when you define a type class and type class instances in Haskell, you don't have to say what scopes you're going to use those in, right? They're just global. As soon as you make an instance of a type class in Haskell, it is available globally in your application, right? In Scala, you have to bring it into implicit scope. And then it only exists in the scope that you bring it into implicit scope in, right? So
With
implicits
the
are,
exception of those things that are brought into scope for you automatically by the compiler,
yeah.
which are a special case of the same mechanism.
Yeah.
Right, so that muddies the waters even further.
Exactly. So like predef is loaded with implicits. So like predef has what equals in it. So you can equals anything with anything else. That's a function. It's an implicit function on every single type. So these things exist in the Scala compiler proper, in the proper language. They're everywhere. And that's how the was the collections library works also with implicits that are just brought in with pre-def. Yep. All right, so we're just going to talk about implicits now. So we're going to, so here's what we have so far. Right? We have zip as a type class. We have zip as a function, which uses that type class, right? And just for S and Gs, we've got an instance of that type class, right? So this is how you zip two lists together. You just call a.zip. All right. And then here's how you use it all together, right? So we're zipping two lists together with our function. We just pass the two lists in, pass the type class instance in, and voila, it just pops right out. Right? So this is really annoying to pass in the type class instance every time you need it. Because if you use multiple of these, right, it just gets really unwieldy, right? This is disgusting. Right? So at some point, you get to a place where you don't want to, where doing things type-driven just looks terrible, and it's difficult to read, right? So implicits help us to manage this a little bit more here, right? All right, so with implicit becomes this. You put an implicit in the type parameter, in the value parameter list, right? And then you implicit your instances, right? And then you just do the same here, right? You put implicit in your parameter list, and then you can just call implicitly, right? And it just like falls out. All right. This is how you clean this up a little bit, right? So implicit is super important. Implicit just means compiler, do this for me, if you can. And if you cannot, tell me why, right? So again, we're using the compiler as kind of a lab assistant, right? If you don't have an implicit scope, something that's an F of A, the compiler will tell you, I cannot find an F of A. You need to get there, right? So it helps you along the way to define a correct program. And all of these are the same, right? Zip3, implicitly. Zip4 is just implicitly. Zip5 is just implicitly, right? All right, so
that implicitly, it's almost like a verification. It doesn't do anything specific other than confirm for you that the previous line was correct.
So it tells the compiler
Generate
to
code.
write the code for me. That's what it says.
All right.
It's basically saying infer a transformation from something of this type to something of that type
Yeah.
using implicit rules already in scope, notably those above.
Yeah.
Okay, so basically, from that point forward, zip3 is defined.
Yeah.
That's the first example.
Mhm. Yep. So the implicit in front of the def is super important, right? Because that means that the function itself can be called by the compiler, right? And that's how we get these, right? Because this is a nested call of this function, right? It doesn't just get called once, it's called nested. But because the compiler has the function itself to call, it can just do that, right? So it just kind of steps down until it finds something that it can do.
Because this is all static, the performance is not bad.
The performance is the same here. So it is statically verified.
Yeah, right,
But
because
it
your
does-
counter output is not dynamic, so it's
Yeah.
not.
But it does actually create a nested call of the
Sure, it's correct.
But in this particular case anyway, that's exactly how you would have implemented it to begin with.
Yeah, that's exactly how you would do it anyway. So there's no point in typing that.
Right.
All right. And with the shorthand, you can do it this way, right? So this has no value parameter list, right? It's all just type parameter list. Right? So F, there is a zip instance for F, right? There is an F instance for A, right? That's what this means, right? This is an F of A is an instance of F with A inside of it, right? Okay, so there's an instance of that for B and for C, right? That's what these mean, these colons here. And they just call implicitly, right? Zip 4 and zip 5 are done the exact same.
Everybody in here knows the colon syntax, right?
Yeah, does that,
It's not new to anybody in here.
I'm new to it.
They're referred to as.
This is the,
Yeah, so
They're referred to as
I know.
context bound.
yeah.
This is exactly, I mean, the compiler tells you in the commented line underneath what it really is short for.
Yeah, so.
Because you can do this manually.
You can do this, like, and this is identical, right? Pretty much, except the names are terrible here, right? To what this looks like, right? So you have your F, A, B, C, and you have your implicit, and you have your, well, this,
The order is
yeah,
different.
the order is different, but the idea is the same, right? So. All right. So,
So I have a question.
Yeah.
If you use this, because it's a smart trick to use implicit search to write your code for you. But this means if I wanted to zip two list ints together, how would I do that? Because I can't. How can I have two lists of implicit scope at the same time when I want to call this?
yeah, you wouldn't be able to do that. Yeah. So that's the thing. This is type-driven development, right? So your types should define your application wholly, right? And specifically. So if you
Well,
can
maybe
flip,
insert that example, so if you had
If you-
two, go ahead, sir.
if you can flip two arguments, it's invalid, right?
So does that mean that for the purposes of this presentation, you want there to be a thing that we're at for any type there is at most one value of that type in your entire program?
So singleton types and shapeless witness really help when you're doing this type of thing, because then you can really get to very specific instances of your classes.
This complicates writing things like binary operators, though.
Yeah.
Right, anything that has a commutativity associated with it.
So it does and it doesn't. That's why we have type classes, right? So we can lift functions like that into the type system. And then, so that commutative operator comes in as a single type.
Okay.
And that type class would be the semigroup. So yeah, so this, right? So we've taken out the zip parameter, value parameter, as a type class, and we've taken out the list value parameters the same exact way, right? So list is a type class, right? So list, specifically, it's called the free monoid, right? So if you have a type, right, that list is parametrized with, you are guaranteed certain functions. So that type parameter and that set of functions are now bound in the type system, right? Statically at compile time. That's all it means, right?
List is a monoid, clearly. How is it a free monoid?
Because you can shove anything you want in there, and now you have a monoid.
Oh,
Yeah.
because there's no data loss.
Yeah. It just you're trading stack for heap, right?
So set wouldn't be a free monoid, would it be?
No, because it's lossy.
Right.
Multi-sets would be a commutative model.
Correct.
Or commutative group, really. If it was multi-set, you could go negative. Either monitor or depending.
Interesting.
All right, so all, for the purposes of type-driven development, all a type class is representing in the type system functions, right? That's all it is. All right, are we okay?
Types representing functions.
Yep, types representing functions. So that's the idea of type-driven, right? You're driving your development through your types. So anything you can represent in the type system, you will represent in the type system.
Okay.
That's the goal, right? And still, we're just refining. We're refining and refining and refining. It's the same function, it's refining. All right, so that was just introducing implicit. We didn't get anything more into the type system. With that last step, we're just introducing implicit so that our code can look a little neater, right? So now we're just going to do a little bit more, right? So our zip type class seems pretty cool, except it requires tuple 2, right? We don't want to require tuple 2. We want to use whatever the heck we want, right? Because not every application is products, right? Some applications are sums, right? So products represent, we're doing both of these things, right? And sums represent, we're doing one of these things. Most of your applications are probably sums, right? If you're doing an if, that's what you're representing, but at the value level, right?
Right.
You're saying I'm doing this or this, they're exclusive.
And enumeration is the prototypical
Yeah.
sum.
Yep, yeah. Enumeration is the simplest one. Yeah. All right. So yeah, we can abstract that out the same way we abstracted out lists and vector and stuff like that. Right? We put a different type constructor, but it takes 2 arguments instead of 1. And then we write our zip operation with respect to the new G thing instead of knowing that it's a tuple 2. Okay. All right. So now we need a new instance, right? So this is for list and tuple 2, and it's exactly the same. We can do it for our and type, right? It's a little bit more complicated, but it works, right?
Hold on, the zip line.
Yeah. So all I do here is count the zips and say whichever one. Yeah. So you can't zip past the length of the list, right? So the zip for list and checks the size, right? So whichever one's smaller, that's the size of the output list, right? It just can't be. There just aren't enough values to make it bigger than that.
But you could have written this recursively if you wanted to, right? Instead of
Yeah.
having to do the size and the indexing.
Yeah. I wanted to keep the complexity as low as possible in the business logic, because the business logic's not the important part. And then we can do it for or as well. Like we can do this for as many as we want, right? As many things with 2 type parameters, type constructors of array 2 that we want to do it. We can do it with either or whatever, right? And then here we have our implicit values, right? Our implicit instances of our list type class, right? Everything is implicit. So here are instances of our type classes, right? Every type class instance goes implicit. And you can imagine this is some kind of business logic here, right? That's why I made them defs. Because in the real world, you'll have something here that says, calculate this value, right? All right, but here we're just going to keep it simple and we're just going to make them values. Oh yeah, so yeah, that won't fix bug that that I was talking about earlier. So there is a compiler bug. The order in which you put the implicits here does matter. Yeah, it's insane. So there's a really insidious compiler bug that because of object orientation, right? And the fact that Scala has a top type and a bottom type, right? And it's a confluence of things. the top and bottom types, so the top type is any, the bottom type is nothing, right? The top and bottom types are poly-kinded. So if you put a really complicated implicit, like really complicated in like a very simple way, you know, in the type, like really complicated in the type. So zip takes two type parameters. The first type parameter takes a type parameter. The second type parameter takes two type parameters, right? That's a complicated type, right? So if you put that last, as the compiler is trying to unify the types, it infers that as nothing or any, depending upon what position it's in contravariant or covariant position. And then the whole thing explodes, right? But if the compiler unifies that first, it works. They know why, but it's a won't fix, but it should be fixed in Dotty. That's what the GitHub bug says, at least. Yeah. So just rule of thumb, super complicated types go first in an implicit parameter list. Super simple types go last. Rule of thumb.
And the compiler has a dash flag that you can turn on to tell you about super complicated types or order them, or do you just switch them whenever something blows up and everything's recording?
If something blows up and it's mathematically sound, you just like check. You just look it up. Yeah, you just keep moving stuff around and then eventually.
So what's the symptom of blowing up in this case?
You'll get a compiler error, and it will say that it will tell you, what's it? It's what does it say? I forget exactly.
Well, first of all,
I'm gonna do
thinks
it,
your type
and then
is nothing.
Yeah. So it
Most
infers
of
it as
the
nothing, but
time,
it doesn't
yeah.
say that.
No, you're right. It
That's
doesn't say
what's
that.
happening. If you debug in the compiler, that's what it's doing. It's inferring the bottom type or the top type, depending upon if it's
Doesn't
in
it?
covariant or covariant
Right.
position.
Right.
And then it infers nothing, and then it explodes in a really weird way, and it doesn't tell you.
Doesn't
really
it
what's
say
wrong.
like implicit resolution can't be done for some really
Yeah, for
weird
something.
reason?
Yeah. It tells you that
Okay.
it can't find an implicit, but it's really, I don't know. Yeah. So I forget exactly. To my knowledge, like me and Sam Halliday are the only two who have like run into this bug.
I
really,
saw
like,
this.
in production.
I saw
And
this in
he-
Slick.
Yeah. So
Where I
so-
put my query type, because each query type has 3 object parameters. I put my query type at the end.
And then they can't find
Yeah.
it, right? Yep. They can't find the implicit. But if you put it in the beginning, you're probably fine. So yeah, he wrote the bug in GitHub. And then I ran into the problem and I searched and I found that I was like, so yeah, it's a real problem. But anyway, yeah, so do that last, right? So we write our things, right? We have zip, and then we do whatever the heck we want. Yeah. So these are the same. Look at that. It's very wet. All right. So
That's kind of the purpose of doing this here, right?
yeah, for test driving it. Yeah. So the business logic, right, gets super simple. Right. So all we need to do is tell it what types we need, right? All we need to do is declare. And that's the entirety of our business logic, right? So we did all kinds of like trickery and witchcraft. And now we deliver our library to people who are not developers, right? Because most of the people who write code do not have a degree in computer science, right? So we deploy our library to non-developers, data scientists or what have you, and all they have to do is say what types they are working with, right? The compiler does the rest. This is really easy to deploy in an environment where you don't have very many software developers, right? This is really difficult to deploy in an environment where you have a lot of software developers. Software developers are like, I need to change the library because X, Y, and Z. And you're like, no, you don't. All you need to do is write the code the way the compiler tells you to write. You know, so the audience for doing this with are people who are just like, screw it, give me the library, I want to write as few lines as possible, and then get back to work, right? Because their work, their real work is not doing software, right? Their real work is figuring out what data they can pull out of the data lake, right? Okay. So it's very difficult to deploy this in an environment with a lot of software developers. I found that is, right? Because they all want to change the library. Yeah,
So that explains why it's the Spark world and whatever, and kind of it gravitated to kind of together, I guess.
Yeah.
Scala and applications with that use case.
Yep. All right, yeah, so we can do this here. And then for and, right? And then for or, right? The only thing that has changed, right? The only thing that has changed is this part of the line, right? So less than a line change, and you get totally different semantics in your application. Right? This is an entire application, and we've changed how it behaves with a less than one line change. And you can do this ad nauseum, right?
Can you get to the point where it just says main CRP and equals implicitly?
Equals it. You can.
Have you ever tried it?
I caution against this.
Have you tried it?
I have, and I caution against this.
Awesome.
Because if you have
That's
like,
good enough.
yeah,
That's good
because
enough.
if you have an error anywhere, like a real logic error, like business logic is wrong, then it's really difficult to debug through that. And by debug through that, I mean like get an error out that's meaningful, right? Because we're talking about like now it's
Gotcha.
yeah.
Well, in effect, I mean,
But it's doable
in effect, to get that to work, you have to have so many implicits in scope
at main.
at main.
Yeah.
And that's the problem, because it's not, in a sense, that kind of violates one of the functional principles, basically, which is
Main
I should be able to, well, I should be able to, that, or I'm trying to be able to read the code at some level and know that what I'm reading is what is actually going to happen,
Mhm.
right? I mean, just to distill all of that down. And a main is defined implicitly. I have that relies on 30, 50, or 100 implicits to build the code at compile time.
Yeah, no.
I haven't a prayer of looking at that
Oh,
and figuring out
totally.
what's going on.
So that's why the whole time I've been like, when you put this in your library, right? This is like, you build your library this way, and then people build business logic around it, right? Or in it, or with it, or whatever semantics you want to do. And that's like normally what happens, because I mean, Scala is object functional, right? It's not a purely functional language, which is why when you try to do purely functional programming in Scala, you run into like crazy brick walls and compiler runs, right? because it's object functional. So there's a lot of object orientation that's like good, right? And we can take from that and we can use it. But there's a lot of functional that's really good that we can take from that and use it. And so this plays really nicely in that kind of world, right? You bundle this up into a library. Your library is sound. You know it's sound because the compiler verifies it for you, right? And then people using your library have confidence, right? Assuming they use it the way you want them to use it. And one way to guarantee they use it the way you want them to use it is typing.
Or it might be exactly the opposite of that, where they are just so bamboozled by the library that they use it consistently incorrectly, right?
Yeah. Yep. That can work too. Okay. So now we're going to define the non-empty binary tree. Right? That's what we're going to do as the exercise. Awesome. All right, we're almost done, right? So what we have is a zip, right? We have f of one type parameter and g of two. And what we're doing is we're taking things of many f's and we're creating one f with nested g's, right? And g takes two type parameters. Right? So pretty much done. So we can take tuple 2 as g, right? And as f, we need a type that, given an a, ensures an a, right? That's the identity at the type level, right? Given a type a, we need to ensure a type a. All right, so we can do this as the identity, right? This is a bad idea. Don't do this in real code. Because it actually exploits an unsoundness in the type system. Because this should fail. Because A can't equal anything except for A, and that's what we're saying. It equals the identity of A. So where do you stop, right? Where does the type checker stop descending, right? I see an A, let me wrap that in an identity of A. I see an identity of A. Let me wrap that in an identity of A. I see an identity of A. Let me wrap that, right? So this is actually like an unsound thing, and it should not compile. But whatever, we can do is, I mean, we're careful. So, because we're disciplined. But like, yeah, just don't do it in production. This is just to illustrate the point, right? All right. There are sound ways to write an identity. But yeah. All right, so non-empty binary tree is just zip of identity and tuple 2. Okay. That's it, because we have to have a tuple 2. That's what identity means, right? So we can't have empty. We have to have a tuple 2. And then that tuple 2 can be, the left and the right can also be tuple 2s, right? So each branch is a tuple 2, and each leaf is some proper type. And that's how we get a non-empty binary tree that is verified in the type system, that the types are where you want them to be, right? So each leaf is a different type. So with something like singleton types, you can guarantee that you have a binary tree that is, that is ordered, where you can guarantee that you have a binary tree that's unordered, or something like that. You can make guarantees statically at compile time, right? Not at time. So this is where like the huge performance boost comes in, right? Because we're doing that statically.
So what's the reason for using identity of A instead of just A here?
Because so this is the free type class, right? It takes any type and produces a type class out of it, right?
Okay.
So here, zip takes a type class, you can see that as its first parameter, right? But we don't want a type class. We want whatever type we have, right? So we use the free type class.
Yeah, in terms of the body, you could actually just write A colon A and B colon B, and it would be just as good.
Yeah.
So it's just you needed a type constructor for something that's not a type constructor.
Mm-hmm. Yeah.
You could also do the null type alias where it maps A to unit, and then that also works for anything.
Mm-hmm.
You always get unit out.
Okay. Yeah, so that's what we do. And then, we just get a binary tree out, right? We declare our type, and then the compiler out pops what we want, right? So this is like a very, very declarative way of writing code. You have to do all this like fancy stuff up front. But after you do all that fancy stuff up front, like forever, you don't have to do anything fancy. All you have to do is declare types, and the compiler does the rest. All of the rest, right? All right.
What happens
So-
if you need multiple longs within, identity int long,
Yeah.
long string double?
So don't do it like this. So this is where more complex systems come into play, right? So we can take this that far, but this is where like witnesses and singleton types and all that stuff come into play. When you want to divide types that are indivisible in the type system, right? Because that's what we're talking about. So those two longs, in your business logic, they mean something different, right? Right? So if they mean something different, they should be different types, because this is type-driven development, right? Everything that means a different thing should be a different type. If you can swap them, you've done it wrong.
So a good example of that might be a double latitude longitude.
Yeah.
They are both encoded the same way, but you want them not to be able to be passed in the wrong order, so you should
Yeah.
lift them up into each one of them into the
So
type
let's say
system.
we've done this and we have, so I think if they're literal singleton types, then I think it's pretty clear that in the type system, that the exact binary tree is, 5, 3, whatever, you've got the numbers and that works. But let's say we've done this, but not with literal singletons, but just with other singletons that are typed as type aliases or type members or something. What are some algorithms that I can use on this binary tree? Can I search it? Like, how would I write up something to search that binary tree or to do stuff with it?
Yeah.
Because the types have nothing in common necessarily. So what strategy would you use to work with that structure?
So
You need to have him in your audience as a shill, by the way.
I was thinking the same thing, actually. You having a foil on
So this is-
stage would be really
Because I
interesting.
guarantee you, he already knows the answer to the question he's asking.
So you do kind of the opposite. So we have a zip, right? So we need an unzip. So we need something that takes an f of a, produces for you an f of a and an f of b, right? So once you have an f of a and an f of b, and a and b are not f's themselves, right? You're done. And now you've destructured this thing, right? So it's very similar code. It's almost identical, but reversed. So type-driven development, if you know enough category theory, right, it really simplifies everything, right? Because now what we're talking about is we're in the category of zipping stuff, right? It's category of types in F, right? That's our category. And now we're going from, and our arrows go from AB to AB, right? So we have this category. And what you're talking about is just the dual category, right? And we encode it almost identically because it is the dual category. So everything becomes super simple if you know enough category theory and do type-driven development.
So the way to search a binary tree of arbitrary types is to flatten it?
So searching, you don't have to flatten it because you can throw stuff away, right? There's no memoization there, right? Flattening is different, right? So what I just described, unzipping, is like kind of your search, right? Because you're not memoizing anything. You're not creating a structure as well. Flattening is you're also building a structure, right? So this is where like lenses and stuff like that come in.
Oh, so hold on, let's see
yeah.
if I understand what you're saying. What you're saying is that essentially in your unzip, you would create a lens, and that lens would do the extraction.
No. So
No?
so in your unzip is just your result of your unzip is just the f of a and the f of b. They have nothing to do with each other. There's no real structure that you're creating.
Okay.
Whereas in a flatten, you're creating a structure, right? You're destructuring and you're structuring at the same time.
Okay.
So this is where like folds and unfolds and all that fancy stuff come into play. Do you know the library Matryoshka. That's what that library is for.
Okay.
Yep, that library is this stuff, but like super generalized, right?
Okay.
Folds and
You know, I know this question is gonna go kind of the other direction, because I'm gonna confuse logical with physical, it's always a mistake. So it strikes me that that's the essence of MapReduce, in terms of you moving the function to the data, not bringing the data to the function.
Yeah.
You're kind of, because you manipulate things at a functional level, you're able to push it out towards, you don't have to create an artificial structure. You're basically using it at its core, the functional.
Yeah.
Is that a reasonable? I know it's a data.
Yeah, so MapReduce can be used, you know, to kind of, you take this unstructured stuff, right? And that would be like your declarative type, right? In this kind of program, right?
Yeah.
And then you do your mapping reduce, and you get something structured out of it, right?
Right.
Yeah. This is kind of like your map reduce inside of the type system-ish, you know? So you're saying, I have all of this crap in implicit scope, right? Structure it for me, right? Whereas MapReduce is like, I have this stream of data, structure it for me.
Yeah.
Does that make sense? Ish?
Yeah, you know, I work in very large NoSQL implementations.
Mm-hmm. Oh man, how's that work for GDPR?
We're busy. We're doing pretty well.
Yeah. Right. Making money.
But the data types are get to be relatively enormous, right? Because NoSQL, you know, it's a big data integration, so they basically become denormalized trees.
Yeah.
And they can be really huge.
Yeah.
So the idea of how to have a strongly typed navigation of that, something which I don't think, quite honestly, I'm not sure we have a clue yet. But a lot of our customers are struggling, we're kind of barking up that tree.
Yeah, to get it right in production takes a while. But if you do, then your runtime goes way down.
Oh yeah.
And so you save a crap ton of money on like whatever cloud service you expect, right?
Yeah, it's
worth it.
Yeah, the payoffs, you know, it's what I get kind of fantasies about. Knowing how things are implemented and how to, you know, okay, something like a load balance. Yeah, it seems like a really logical thing.
Mm-hmm.
People are killing for like 5% increases in performance.
Yeah, because that translates to like millions of dollars in some situations.
But just looking at it from a systems perspective, I think there are important performance improvements of 100-fold are possible.
Right. Yeah.
And there are other fields like, you know, that have experienced this too, where you take like two things that seem to be separate concerns that are handled in silos, and then somebody comes along and says,
They're the same. They're the same. Yeah.
Yeah. And so we're doing all this structuring just to get it over here. You know, browsers, as an example, were implemented as parsers and renderers.
Yeah.
And
but you can do that. Yeah.
So I don't know if this is exactly what related to Marcus's talk, but speaking of type-driven development, there's for exactly the problem you mentioned of serialization, deserialization, right? Where you're serializing data in one place and you're deserializing somewhere else, like say on a different machine, but you know it's the same bytes. There's actually a cool trick you can do that my colleague Oscar tweeted about a while ago, where if you have a serialization type class where one of the member types is an output type that's abstract, you can, when you go to deserialize, you can let the type system prove to you that it definitely came from this serialization, so there's no way it can fail. So there's no try, there's no option, there's no error handling, because you know that literally the same instance was used in both places in the type system. And then at runtime, of course, maybe it's just array bytes or byte buffer or whatever you're actually using, but the compiler had no way of knowing that when it actually compiled the thing, so it proved that type information is preserved, and therefore it had to come from the system, because there's no other way to build this abstract type. So you can use these kind of tricks to get more soundness in your systems, and you can be sure that, like, for example, if you have like different serialization schemes, like if you're using protobuf or 3-abstract Captain Proto, whatever, they're all at byte buffers, so you get them mixed up and you do the wrong one. But if you do it this way, you can kind of have like these abstract types where, like, I know this one came from protobuf, I know this one came from, whatever. There's no way of mixing them up.
What's this library called?
It's more like a pattern. We have an internal library we build on it, but I'll share a link to the pattern. I mean, it's just like.
So that was gonna be my question.
So that's-
Yeah, me too. Download this.
That's
Is this on
methodology
Central?
that I use a lot with phantoms. See, if you make a trait, a totally empty trait, name it something, you can thread that trait through as many functions and whatever as you want, right? And as long as it is the same in every single call, all the way down the stack, all the way back up the stack, you are guaranteed that data is the same, right? Wow. And that trait, because it's a trait, it just gets thrown away by the compiler because there are no values of it, right? So it doesn't exist at runtime. So instead of like having to check stuff in every function, right? You just do it in the compiler. You pass this trait down. And so every function that requires that as an input parameter,
So I have a broader question.
Yeah.
And I'm asking it now because I don't see another lesson.md tab up there, which says to me you're done.
No.
Okay.
There are more, but they're not as.
Well, no, but I mean for this evening.
Yeah.
Yeah. So at an abstract level, this stuff all seems great to me because you're pushing all of this stuff up into the compiler.
So the next section is called the real world.
Well, but the question I have is maybe not even the real world.
Yeah.
And I do want to see this section, and you can defer to answering my question to the end if you want. But my problem with this is not that I don't see the value of it, but that when I sit down at an editor with a blank Scala file in front of me, I'm not sure how to start doing this.
Yeah.
Right? So you were at that point at some point, and I'm wondering.
So I was at that point when I wrote the zip function, right?
So how did you bootstrap yourself to where you feel fluent doing this particular kind of programming, I guess is where I'm going with that.
Yeah, I'll answer that. This part's like pretty quick.
Yeah, no, that's fine.
So
Defer
we'll do
that
this
to
in a-
whenever.
Before we move on, sorry, what's your name?
Eric.
Eric. You mentioned like 2 other ways you can get rid of not having identity.
Yeah.
Can you just say them again? I want to understand what they are and why they work.
Oh, do you mean like how identity of A is just equal to A? So-
You mentioned, right, so
Okay, so the other ones, so basically what I mentioned is, so in Marcus's code, anytime you need a type constructor with one parameter, he basically invented identity so that he could use A values as if they were some type, applied to some type constructor.
Right.
But he didn't have a type constructor, so he had to invent one called identity. The point I made, which is like kind of a weird one, is that identity is not the only one of these you could do. So actually you could have one that takes a type constructor takes the A value and then throws it away. So no matter what A you give it, it returns a unit. So you'd have like type null of A equals unit. And then you can now, if you have something that requires a type constructor, you can pass it null and it's not even going to use the A, it's going to throw it away. It's essentially like erasing all the type, like it'll do nothing basically. It's kind of like a no-op type constructor.
okay, so if instead of identity of A, you would do null of A.
Then in
What
his
would you
code,
do?
then his code, what his code would mean is, you see that binary
So
tree down there,
instead of A here,
Okay.
you would put unit.
like open parenthesis, close parenthesis, the unit value.
Oh.
Or actually, sorry, unit type in that case. But then if you scroll down to where the binary tree is, a little bit further, right there at the very bottom, that res 0, you see how there's like 1, 4, 5, 2,
Yes.
3. If you had done that, all of those would be units. There'd be no numbers there. You'd have something of int long car string double. It would claim to be of those things, but actually it would be unit because it would have erased itself
Okay.
to the unit value and all those.
Okay.
So you can use that if you never need to destructure this type, right? if you're just creating this type and just dumping it out somewhere, you can use that and it will be more efficient.
So it's like technically effective.
Well, yeah, it basically is something that the type only exists at compile time. You're throwing away all the information at one time.
Okay.
Yeah,
What was
but if
the-
you need to destructure it, you can't have
Right.
Yeah.
Right. Okay. What was the other way you mentioned? You mentioned like a second way.
Well, there's another one, so you could actually do nothing, and that would be like the impossible type
Yeah.
constructor.
Okay.
And if you did type impossible A equals nothing, that's something that can never be instantiated. So if you did that, then your program would basically fail to run. When you actually try
Okay.
to go run this thing, it's like there's no nothing
Yeah.
values that you would
Yeah.
be passing implicitly, so the thing just wouldn't compile.
Okay.
But locally, it might compile. You just would never be able to actually run it.
Okay.
There's another problem of poly kind of nothing.
Uh-huh.
Alright, so, there's a note here. So when we go from identity to list, we have a list of non-empty binary trees, right? So it's much better to use a singleton list than an identity, just so that the type system has soundness. So at this point, if you're in a REPL, you need to clear it, right? And then redefine the zip stuff, because nothing else will compile if you have that identity defined. A equals A. The compiler cannot figure it out because it can implicitly.
Because it's infinitely recursive.
Yeah. So the compiler can't figure it out. So that's why you don't do that anymore. Yeah. So in the real world, you don't define that thing because you just can't do anything with the compiler after that has been defined. It's the compiler's shot, right? Or implicit scope. Yeah.
Do you recommend people use a singleton list instead of just defining a case class? Because if you did case class singleton of A, then that would be safe, right? You wouldn't have the same problem that identity would have, but also
Yeah.
it would only ever have one value, whereas list that you kind of relies on them using it, right? So if we're doing
Yeah, that's an awesome idea.
type driven, yeah.
That's actually really good. I'm gonna add that to my list of things to do. Oh, good idea.
Wait a minute.
So,
You're allowed to declare case classes that have no parameters?
Well, this would have one parameter.
Yeah.
It's a case class that just wraps a single value.
Oh, okay.
It's like a no-op because it always has exactly one,
Right.
but it just
Right.
gives you a different.
so it's
Essentially, it's a way
analogous to the singleton list.
essentially, it's a way then, if I understand that properly, that would be if you needed to distinguish at compile time between a latitude and a longitude that were encoded as doubles, you would wrap each of those in a case class with a different name, and that's how you would insist on using them. Therefore, they can't be, you can't be used in the wrong way, even though they're still encoded as doubles.
That's right.
Okay.
Isn't a sum essentially
Yeah, you
the
could use
equivalent
some
to?
for that too. You already got some lying around. Some
yeah,
also
yeah.
works if you type it as some, not as option.
Right.
And sum is the singleton class. Case class. It is a case
It could
class,
be,
right?
yeah. I mean,
It is a case class, and it's just one thing.
Exactly.
It's
Yeah,
exactly the thing.
What's interesting is that none is actually unit.
Yeah, I mean, right. If you wanted to represent as a co-product, option is just basically, sum of A, or
Yeah.
you could use unit and you could use like any singleton type constructor as an option if you want to roll your own.
So this is interesting. Like in that famous interview question where they say like, what are the empty types in Scala?
You're like,
And none is like one of them. No. None is not an empty type, because if none is an empty type, then unit is an empty type as well.
Is that a famous interview question?
I don't know. I've seen it on Scala times. Like, and
I've never
I'm
heard
like
of
not
it.
sure what that means actually.
yeah, the empty
So-
size.
well, they're supposed to.
Nothing is
You're supposed to
Yeah.
right. You're supposed to say nothing, nil, and like what the difference between them. It's like basic kind
For
of.
some
But
definition.
nil is
of
also
empty,
unit.
That's
I
incorrect.
think that's,
Yeah.
Nil and none are nil is also unit.
That's actually a
If none
good
is
point.
unit, nil is unit.
So in that case, nothing is really the only absurd
Nothing is the
type.
only
They're
uninhabited type.
all. Yeah, they're all terminal.
All the other ones have actual values, so they're not empty in that sense.
Hmm.
If you just mean empty, like how you feel about it, then sure, they're
I don't
all
feel
empty,
nothing
I
about
guess,
it.
right?
We don't
There-
care about your feelings.
There was a time where I remember two developers, one from a math background, one from a pure computer science background, arguing whether there should be a difference between null and empty lists. And they argued for like an hour.
Okay, so
Yeah.
Just,
So-
it's
so
just a program in
real-
JavaScript, is it wasn't there? Yeah. Excuse me.
So at some point, we have to like do stuff, right? Like a user's gonna send us stuff, and we have to switch on the stuff that the user gives us to produce the result that they wanted for that input, right? And then for a different input, different result.
As contrasted with your examples where those results were just implicit.
Yeah.
Yeah.
Yep. All right, so how do we do that with this? So what we have are trees, right? So we have lists of trees. That's what we got. Right. So let's do this. All right, so we have two trees here, and what our process does is take our tree, right, and then does something heroic with it, right? And that's our business logic. So we shove our business logic inside of some function somewhere, right? We don't care what the business logic is for the purposes of this workshop, right? This is where your business logic goes in. All right. All right, so our application, if we would take our ID, our user input of some kind, right? And if it's a 1, we process tree 1. If it's a 2, we process tree 2. Otherwise, oh no, right? All right, so we do the same thing, right? We refine this. We lift this into the type system, right? So we lift proper types like int or whatever into the type system with a type parameter, right? But we also need to hook this up to our tree, right? So we have a tree and we have an ID and we need them to be together, right? So we do something semi-fancy, right? So we make a tree ID type class, right? So we get our int, all of our IDs are ints. We get an int, and we just have this fancy little this little type parameter right here, which will be our tree type, right? We also have another function, tree processor, which has a process, right? And which is this function, right? We take functions, we lift them up as type classes, right? Okay. So we have an ID, we have a way, so that distinguishes a tree. We have a processor, which processes a tree, a specific tree, and then we have a tree, right? And an application, right? So our application, same thing. We lift it as a type class into the type system, right?
For the application, you're not using the ID parameter anywhere. Did you need to be using that somewhere?
No.
Okay.
So this is another quirk of writing code this way.
Okay.
This is one of the quirks.
Yeah.
So we define in the type system a whole bunch of stuff, right? And we define functions that seem like they're disjointed, but the compiler knows what it's doing. So we're okay, right? So now we need a constructor for this type, right? We need a constructor. We put it in the companion object. This is the pattern in Scala of doing these things. So like if you read the code in Shapeless, this happens often. I was about to bring up what you said. So we don't use the ID here, right? But the function here, like it has to be something, right? So we define what it is exactly in the companion object. So if we have an ID and a tree, then we have a tree ID, which takes that ID, right? And this is what I was talking about. You have some phantom type that you thread through everything, right? And then you're guaranteed that it is the same, right? So we have a tree ID of ID. We have a tree, which is some type, right? Which for us is going to be f of g of whatever, right? And then we have a tree processor of tree, right? All right. Cool. And then we just do our, if the ID, right, else it's not, right? So, all right. Our function takes it in. Okay, so here are the exercises. This is kind of as far. I do have more things. Not quite. Okay. All right. Oops. What was that? That was it was what? 4. All right. So this one's not quite cleaned. We're going over, but we'll hold on. How do I? I'll just make this bigger. All right. So yeah, let's just do it this way. All right. So all right, what we want to do is we have a function that takes an ID and returns an either. Right? So what we're going to do is we have our IDs, right? And so we have a tree ID for 1 and 2. We have a processor for our tree 1. We have a processor for our tree 2. And we have an application for both of our trees, tree 1, tree 2. This is what I mean, like the compiler threads everything through top to bottom, right? So it just knows which types to grab because it can only be one way. There's only one combination given the trees that we have, right? And then we just write our function, right? So application 1, that process ID match. If it's a right, we're good, right? Stop. If it's a left, we can't stop yet, right? We go into the second tree, right? We process the ID. If it's a right, we're good. If it's a left, we just return unit, right? We're done.
So here in this case, left means it's not been handled yet, and right means it has been handled.
Yeah.
So when you hit a right, it's been handled. Left, you have to keep.
Yeah. Here, that's how we're doing it. So if we get a left, we get our ID back. If we get a right, then we've gone all the way through, we've exhausted all of our choices, and nothing came up. And that's why it's unit, because it's literally nothing has happened. So we use unit there. All right. All right. So tree processor instances for this and 2. All right. And here's our unzip, right? So in order to get a tree processor, we have to unzip the zip, right? And so unzip is almost identical, right? So we have F and G, and we have our F of G, and then we have to just look, right? So instead of having an F and a G, instead of having an F of a G of both of those things, we have a G of 2 Fs, right? And then for tuple 2, we have this, and then our tree processor looks like this, right? So given an unzip, a tree processor for the left side and tree processor for the right side, we can write our tree processor, right? And this is a pattern taken straight out of Shapless, right? To learn how to do some of this stuff, I did read the Shapless source code. And then I basically rewrote giant parts of it just to make sure I understood it. And now, right? So this is pretty much identical to some stuff that is in Shapless. All right. So, you want to keep going, or does anybody want?
Wi-Fi is good till 9:30, so it's up to you.
All right, cool. Okay, so we'll keep going, right?
Are you going to post this afterward?
If the recording turns out okay, I will post the recording.
Yeah, I gotta,
Because I
put
want
some toot stuff up there, yeah.
I want to print this out and bang my head on it for a week.
Might be
Your week is
somewhere-
like one.
It might be somewhere in my GitHub, but I'm not sure. Like, yeah, I'll just check it into my GitHub. Once I get a moment. All right, so what we're gonna do is we're gonna work with some co-products here, right? Because that's what we're doing, right? We're saying the tree, we're saying the user input, the user wanted either this tree or that tree, or some other tree, or some other tree, right? So this is a co-product, which is a sum type. Do we understand what co-products are?
Yeah.
It's exclusive order. That's all a co-product is, right? It's just exclusive order, right? In essence. All right, so that's what we're gonna write, right? Exclusive OR is either, right? All right, that's what we're gonna use for, because I do not like to type either over and over again. It's way too long, and XOR is better. And I like operators, exclusive OR is an operator, right? It's a binary operator. And at the type level, I like to make my operators all caps because I don't know. It just feels right.
This is like in the spirit of the Curry-Howard isomorphism or something.
Yeah.
The spirit of basic.
In the spirit of async, yeah, that's right. And there are roots in Curry-Howard, yes. Awesome. So now we can say XOR instead of either. There's a trick in Scala where if you have a type constructor of 2 parameters, you can use it in fix, right? So
Right.
yeah. So now we have int, exclusive OR string, exclusive OR double, right? It's real nice.
You can do this with either. All right.
Yeah, you can do it with either, but it's a lot of typing. It's twice as much. It's so long. It's
You could use the Unicode symbol, you circle with plus in it.
yeah. I really like that one, but then like people are just like, what?
So
So
desugar, that's a nested either.
Yeah, so desugar.
Like that.
This is a nested either.
It's an either of an either on one
Yeah.
side.
IntelliJ should have like a loading thing built in.
And yeah. All right, so let's make that work, right? So application, right? Then the object, right? The companion object needs more constructors, right? This is what we do in type-driven development because everything's implicit, and in Scala, implicits are explicit. So you have to tell the compiler when it needs to pull these things into explicit scope. Into implicit scope. So we put everything in the companion object. That's how you do it, right? So our implicit process thing, right? It takes 2 applications and produces a single application with all of our type information preserved, right? So this is going to be ID1 XOR ID2 with tree1 XOR tree2, right? The reason we preserve the type information is so that the compiler can tell us when we've messed up, right? If we do not preserve the type information, right? If we did this and just like said, let's throw away the right side, right? Let's just keep this as ID1 and tree1, right? Now we don't know when we've wrongly returned ID2 or ID1, right? So that's why we make fancy types like XOR, so fancy. So we can do stuff like this. And then this just looks like this. We throw an implicit in there. We throw an implicit in here so that, yeah. Oh yeah, I did not clean this up because there's a warning there. All right, so what we do is we import all the implicit stuff. Then we just call implicitly, right? This is super declarative. Because we have everything in implicit scope, because we've declared our applications, right? We just call it implicitly what we want, and the compiler just says, there you go, right? Right, so, yeah. And then, so, yeah, we can make this simpler by saying, here are IDs, 1 and 2, right? There are trees, 1 and 2. and then we implicitly here with IDs and trees. I really like using type aliases here. It makes the code really readable, especially if you have like big trees of these things, right? Then you declare them as each of your inputs you declare as type aliases, and then move on from there.
So let's see if I understand this. What's happening is that you're essentially using the XOR as something that will ultimately be driven by a configuration of some kind.
Yeah.
And so every single
By configuration, we mean that in like the super general sense.
Correct,
Like even
correct.
user input is configured.
correct. But runtime.
Yeah.
Runtime. Essentially, every single thing that you need to differentiate on runtime, that's what you're using these kinds of constructs for.
Yes. Yes. So the goal here is to make sure that the code you wrote, right? So your ID one had damn better map to tree one, right? It had better. How do you guarantee this? Right?
Right.
So this gets really complicated when you have multi-stage processing, right?
That was my
So-
next step.
So if you have the application is, process 1, process 2, process 3,
Yeah.
right? Process 1's output had better be the input to process 2. Process 2's output had better be the input to
Yeah.
process 3.
I mean,
right?
that's
How do you guarantee this at pile time?
right.
It's really difficult, but you can do it like this, right?
Right.
So here, so the rest of the workshop goes on, and it does end up with that, and you just add more to this application type class, right? So it only takes an ID and a tree, right? What if it took an A, a B, and a C, right? A
Right.
is the input, B is from stage 1 to stage 2, right? C is from stage 2 to stage 3. And then D would be your output from stage 3, right? So you can have multi-stage pipelines written this way and guarantee that everything maps perfectly together at compile time. Because you see how we do it with the XOR here, right? So we have multiple XORs, right? We just keep piling it on. The compiler will just keep figuring it out.
And you have to do this for every single variation of the runtime value.
Yes, but you only have to do it once, right? You only ever have to do this once, and you don't have to write it to ensure that those things match. Right? You have to write tests for your business logic, but the only thing you need to write tests for is your business logic. All of your control structure is checked at compile time, right? Because we do it once. This case statement is the only time we need to check control structure. If control structure is wrong, we change these 5 lines of code, right? And then it's right. And this is the only place it exists.
So conceivably, if you wanted to support multiple data types from Quill that are driven by the different type classes, this is how you do it.
Yeah.
You'd have MySQL and
That's not totally right though, right?
No?
Because app 1 and app 2 instances are there's presumably at some point gonna be some custom business logic for handling particular.
Yeah, so you have to write
Leaves. But as far as the rest of the logic, you're right, it's all there.
Yeah, so the control structure is all here, but the business logic is not, right? So the only things you have to really worry about testing are your tree
Tree
processor
processors.
instances, right?
right.
And those are put somewhere in your code base, and like the warning, touching this will create problems for your test environment.
Right.
Space.
But critically, you only have to test them independently. You can assume that they're going to compose properly. Instead of testing all possible combinations, like what if we use these 3 business logics? What about these 5? What about these 2 in this other order? Like, you don't worry about that. All you worry is the individual tests and then testing the one composition.
Yeah.
Exactly, yeah. They should all compose properly. Guaranteed and compatible. All right, and because these types, the type information is preserved here, right? So the order in which these things happen, right? So when you write your tests, you just write them.
So
You know what the control structure.
So if you had multiple actual pieces of configuration that work together, you would have like an and?
Yes. So the way I use this is I had a single input type, and then multiple process types, and then a single output type, right? So the input type comes in, and it's processed in multiple ways, right?
Right.
So you're producing multiple metrics based on the same input, right?
Okay.
And then you output a single data stream from that, right? And then at compile time, you guarantee that you split those up properly. And from that 1A, you have multiple Bs, and then those Bs map to their Cs, specifically directly at compile time. It is guaranteed, right?
Okay.
So if I'm
Because-
reading this properly,
So the order here matters, right? If I switch these two, this will not compile because it says tree 1, tree 2, right? If I have ID2, ID1, this will not compile.
the only thing that's really binding ID1 and tree1 is that app1 parameter, implicit. That's the only place that equates those two things.
Yep.
Okay.
Yep. Yeah, so it gets, you can get as fancy as you want. But yeah, what was your question again with the,
You hinted at it by saying that you were, that you took apart pieces of Shapeless. But I'm basically.
where to begin?
Well, yeah, how did you get over, there had to be a point when you're teaching this stuff, yourself this, where you're not doing toy problems anymore.
Yeah.
Now you have a real problem to solve, and you have a blank editor screen in front of you.
Yeah.
How do you get yourself to the point where you no longer have to say, okay, how do I get started?
So starting is the easiest part, right? Just start. You write the code, however you want to write the code. Every single time you see that you've written something that looks really, really, really close to something that you've written before, you stop immediately and you abstract that out. However you can, you abstract it out. This is what I mean by this is like all discipline, right? Whenever you catch yourself duplicating, you stop and you rewrite both portions. Right? You just do it. However you can figure out how. And then eventually, you start to just like see these patterns ahead of time, right? At first, I didn't. Right? I just kept working. It's just like, how do you get started with working with, functors and monoids, right? Like you get to a place where, well, you're at a place where you don't know how to use these things, right? And then you write an addition here, and an addition there, and an addition in another part of your code, and an addition in the fourth part of your code, right? And then you read those, and you're like, oh wait, I can just pass in the monoid here, and then converge all of this code, right, into one thing. It's the same process.
So
right?
for you, the way you got there is start writing traditional code and then just force yourself to refine it.
Yeah. If I catch myself doing something more than once, I'm fine.
So I don't know. I think this is maybe like a like converging with what Marcus said. But from my experience, a thing that people in Scala often want to do, especially like if they come from Python or Ruby or some of these other languages, is they want to do metaprogramming to remove complex boilerplate or to remove duplication. But metaprogramming in Scala, you can't really do it the way you would do it in Ruby or Python. And so what I would suggest is basically when people hit situations where they wish they could abstract over their code in the way that a Python programmer or like this programmer would, that's a situation where instead you need to lean on these techniques, basically, that you're not going to have success turning everything into a string and then calling eval or something, and like writing a loop to write your code for you and then evaling it or something. Like in theory, macros sort of work that way, but you know that's not really people are not gonna have a good time doing that. And say that these approaches are like basically the best alternative that exists for like removing duplication. Like you're gonna add, there's gonna be some upfront costs like for setting up the structures, but then once you have that, you can essentially turn the crank and do the same kind of metaprogramming that a dynamically typed person would expect to be doing just by building their code as data.
Yeah.
I think that's one of the hardest things for Scala about people coming from a dynamic typing background. They've got all these metaprogramming skills that they're really good at. They're doing it for a long time. They can write very, very terse stuff. And none of those strategies work at all in a statically typed environment. And they're just really frustrated because they know that they're a good programmer. They know that they're good at this kind of abstract thinking, but it's not translating in the way they expect. And then actually the problem is they have to kind of come at it from this other angle. And then they're going to be using these exact same skills to do type-driven development, basically.
Yeah. It's a really good way to put it. Yeah, so you just begin. So it's type, define, and refine. So in all of these examples, the first few lines was writing a type, right? Writing trait whatever, which takes some type parameter, and then def, right? And that was the first line. So you write your type first, and then you define the instances of that. So how that function is defined is in the instances. You define those, then you refine it further, right? So the first zip type class only took an F, right? And then we refined that to take an F and a G, right? So you just keep refining until you reach your limit, or the compiler has reached its limit. And yeah.
And by reaching your limit, either done or I don't understand this anymore.
Yeah, so either I don't understand this anymore, or I've gotten to a point where like premature optimization is a problem here, right? Like you should stop at the least powerful abstraction that you need to solve your problem, right? Like if you don't need to interchange, tuple 2 with either, with some other types, if you don't need that and you know for a fact that all of your code is going to use tuple 2, use tuple 2. Just stop at abstracting the F. Don't abstract the G out, right? But if you need that extra power of abstraction, then do it, right? It's a quick change, and your old code can typically use it if you use some of the compiler tricks. You don't have to rewrite much.
Yep, makes sense. Any other questions? I'm not seeing any questions out on Google Hangouts. And that's a wrap, man.
Awesome.
Thanks, Marcus.
Here's a quick Spark question. I was using zip here. And, okay, fine. Let's not do it on lists. Let's do it on data sets.
Yeah.
So, but then you have to start passing encoders. Okay, so fine. You can implicit out encoders. But then you have that issue.
Yeah.
So, okay, so just because we have A and B doesn't necessarily mean we have an encoder of A and B. How do you deal with that?
So the simplest way to do it, right, is to have two separate functions, right? One that's normal and one that also takes encoders, which sucks, right? But you only have to do that once, right? Because with the implicits, it just calls itself.
Oh, you know what? There are some questions. There are some questions here I missed. There are some questions.
Yeah, everyone did that. Answer that last one.
No, there.
You should ask it into the question.
There are. This thing wasn't scrolling properly, and I missed them.
Are there tons of questions?
A few, but let me go to the last couple here. First of all, Peter wanted to know if if there's any way to participate in your workshop online at Scala Days. I'm guessing probably not.
I don't think so.
I don't think they simulcast that stuff.
Yeah, I don't think they do, but I could ask them. And
Usually
see.
comes out a few weeks later.
Right.
Yeah, then there's no participation.
Frank asked, are there any pros or cons that are worth considering when choosing how to implement type class instances? For instance, implicit case classes, implicit defs, implicit objects, etc.
Yeah, so there are pros and cons to all of those things, right? So with case classes, you get a lot of baggage. You get a lot of case class baggage. If you want to be super specific with how you use those objects in code, case class is not the way to go, right? Because case class gives you a whole bunch of crap that you can do, right? I really like type classes because it allows you to constrain everything that you want to constrain, right? As much as possible.
Yeah, you're not getting a companion object
Yeah.
loaded with a bunch of crap. You're not getting
anything.
a copy function. You're getting only what you code.
Yep.
Okay.
So if you want to be super specific and have zero power whatsoever, except for what you give it, right? Doing traits and implicits is the way to go. There is another really good encoding called Tagless Final, which is really good at this stuff. Which is really awesome in Scala because it's really object functional, right? It's purely functional at a low level, but it's very object oriented. You write objects, you give them functions, and the types have to line up, right? And that's how you do tagless final. That's how most people do tagless final. There are other ways to do it, but that's how most people do, right? So I mean, it depends on your use case and it depends on your audience, because this is most likely going to be in some library somewhere, right, that other people use. So you're just going to have to figure those things out for your specific case.
And here's another one also from Frank Adi. It says, backtracking. Is there a way to abstract over the arity of the types supplied to the function operating over the type class, like a unified zip function at the call site that figures out at compile time whether it should be zip2 or zip3?
Yeah, so that's just done because zip is implicit, right? So zip just calls itself implicitly, nested as deep as you have memory for in the compiler, and it will work. But also, you can use some compiler tricks, and like the AND type that we defined, you can write a single zip function and just have it take some kind of and the left side or the right side of that and can be another and if you want it to be, right? So now the function just takes an and. You know, if you abstract it, you have to do some abstraction a little bit farther, but with that abstraction, actually the workshop does go into doing that. But you can just use types like that, and then they will have one function which just takes product of some kind, and then it will zip.
And since that product could be a product of a product, you've got your
They can.
composability.
Yeah.
Okay.
The pattern you see in the wild for this is having a function that takes one argument, which is essentially an H list of whatever your input type would have been. It's going to be an H list of those things, and then you're going to have some special, special type class you wrote that's like H list monoid, where basically it's like it asserts that every element in the H list has a monoid, and then you're going to build that up inductively, and then when you go to collapse it, you get an output that's like a list of some element type that's defined on your H list monoid type. So there's like an encoding people use a lot. It's like it seems complicated at first. It's actually not that complicated, and that's generally the way you abstract it over here.
Yeah, it feels complicated, but once you write it, you're like, oh, that wasn't actually as complicated as I thought it was going to be. Right, so like the best advice is just start, right? Because it really does come out to be less complicated than it feels at first. Right? There's some pressure, there's a lot of friction in the beginning, because especially with people who've been writing code for a long time. People who've been writing code for only a few months, I find pick this stuff up really quick, right? Yeah, so because they're not working through all this baggage.
Right.
And this is how I write code.
God damn it.
Yeah. So just start, and then eventually it'll work. Yeah.
Sorry, in the example that you just gave, why do you need a monoid? Why, I mean, don't you get,
So I guess the point is that when your function takes an H list, the only thing from the type system that you know is that it's an H list. You don't know you don't have any constraints on the types in the H list. But presumably you want to do something with those types. You want to know, like, so if we go to the example, you want to, if you have in Marcus's zip function, we want to know that we need to be able to zip these things. So we need to be able to zip the first with the second, zip with the third. But how do you know, if you take an H list, how do you know you can even zip them at all? Where did the zip instances go? Because you remember before he's got 3 implicit zip instances, or 4 or 5 or however many implicit things, and so where do those go? And the answer is you essentially have to encode an H list of those things. You essentially have to build your own type class that says, I know how to work with all of these things, rather than explicitly saying there's 3 of these things, and for each of them I have this thing that allows me to work with it. You say, I have a collection of some junk, and there's a one-to-one mapping between the collection of junk I have and the collection of stuff I know how to do with that junk. And then once you have those, then you can smash them together and say, and here's the kind of result of taking, this aligned collection of junk and collection of capabilities to act on the junk to do something.
so more specifically, the monoid would give you the implicit on the particular members?
So here's an example. So let's say let's say you have stuff you want to add together like a monoid. So let's say, we know that
If we look at this, right? So we have the next part of the product. So we have our and we have our process, right? So and process and application, right? So application composes processes, right? Process composes trees, right? Okay. So application needs to, what it needs to do, where is it? It is in here. So like Eric was saying, you create another type class, right? So application is our other type class. Right? So our and type is our product, right? It says it has as many types as we want in it, right? We just need to know how to create a process and an application out of all of those types, right?
So you need implicits for that.
Yeah, so the application object now, it has it for co-products, which is our XOR, right? It has it for product, which is our AND, right? And is all of these things, right? So they all get run no matter what, which is why it only has 100, right? So this is what he was saying. You need another type class. In this case, our other type class is application, right? So application.
So this is like your monoid.
Yes.
it'd be like your H-list.
Actually, yeah, it would be a monoid, wouldn't it?
These things are monoids.
Yeah, it takes this and this, and creates this and this. So this would be your monoid.
Okay, so your implicits like flow out of your base types
This is your
into
semigroup,
these and
because
ultimately
there's
into.
no empty. So this is your semigroup.
Okay.
You could have, you run an H in there.
Yep. So it's exactly the way Eric is saying.
Hmm.
You can do this ad nauseam, right? It's like it doesn't even. Right. So eventually you can get to a point where I really did not. So have an object. Up. Yep. Yes, I haven't even gotten that far. But yeah, eventually you would have like you can make these type classes as wide with type parameters, as you know.
Well, again, there's a basic,
Modulo memory for the compiler.
Okay.
you talked about kind of writing in Scala for consumption by data scientists.
Yeah.
And that's a divide which I'm spending an increasing amount of time in. Because our product is at a core C++.
Yeah.
And when
You can do this in C++.
when we say something like our analytic users need wide tables,
Mhm.
the engineers are thinking 100, 200 columns.
Yeah.
Data scientists,
4,000, 5,000. Yep.
they're gonna do with 8,000.
No, a
Yeah.
pixel's
Yeah.
column.
Yeah, so like put it in the same table, it's great.
Yeah.
Okay. Just fill it with nulls in
And how
some of
many-
these two spots.
And you ask them, well, how many rows are we talking? And they say, well, why does that matter? So anyway,
Because the machine doesn't have infinite memory. Or it's-
so internally, we've done some really wild things.
Yeah, you have to.
We've got triples and basically unifying rows and columns.
Mhm.
Amazing stuff internally.
Did triple stores solve that problem?
That's the.
Is the
solved
microphone on?
for so it's solved for some value of solve, right?
Okay.
Yeah, that's a tough question.
Specific use case, yes. Every other use case in that.
If you were really had a really good answer for that, you could spend the rest of your life as an expert witness in lawsuits. Because it's a tough deal. But anyway, we got back. There's a real question here. This isn't just the H-list concept of type definition makes sense to me, like from that first perspective. Like, okay, I can go 100 in that world and still be still breathing. So somewhere above that number, that H-list construct gets to feel really gruesome. And we looked at something like the overheads of processing these things, whatever.
So the overhead of processing H-lists really comes in when you try to convert it to a different product type that you want to work, right? Otherwise, the processing time is not, you don't really get hit that hard. So if you can stay inside of the H-list world, right? If you can always use an H-list, it usually works out to about the same performance, right? But if you try to then convert this to like a case class or a tuple, you're gonna get hit, right? Because now, not only do you have this H-list sitting in memory, now you also have this other thing sitting in memory, and they're isomorphic, right? So if your H-list has 3,000 things in it, you're writing a case class with 3,000 things in it, right? Which is a problem, which is a huge problem.
My answer is a little different, which is I think a lot of times when you have this H-list, you're not going to necessarily use it at the row level. So what you might say rather is that you've got like a declarative column type that says I have a column of data, and you might have an H-list of columns, but you're not actually the users aren't working with this. They're not being columns aren't being executed on your your compute cluster or whatever.
Yep.
They're like you've got a compiler that's then looking at this H-list of columns and then saying, okay, now I'm actually going to build the code that's going to run on a compute cluster or whatever. And so you can write code essentially doing like code gen in the compiler of here's my column structure, and then I've got some implicits that are going to figure out, okay, which ones am I going to skip when I materialize this thing? Because probably they're not using all 5,000 all the time, right? So actually, for a lot of these queries, if you have compile time, okay, this job is going to use 20 columns of the 5,000. You can have something that pares it down, says, okay, which things are we going to materialize out of your columnar database or your row-oriented database or whatever you're doing, and then send it off. And then at that point, it looks more like a kind of normal MapReduce job, but you just kind of built it via this kind of like type level programming rather than either doing it by hand and getting it wrong or
Okay, that's
So if you don't need all the columns, get rid of it.
But yeah, I agree that like it gets demoralizing to imagine that you've got essentially a singly linked list for every row of your data, right? You're like, that's maybe not what you want to be working with, right, all the time. But yeah, you don't have to. So for a while, I was kind of down on Shapeless because of that. But actually, what I find, and so if you talk to Michael Pilquist, I think you see the same thing. Is that a lot of times you might not be using those at the row level, or at the actual concrete data level. You're more using it at like the interface level, or the column, or the declarative level to figure out how to structure your computation. And then you might work with arrays of bytes or byte buffers or some kind of iterators, or whatever you're actually going to do at the value.
Makes sense.
Hey, guys, we got 10 minutes till we're out of network, so I think it's, I'm gonna shut the recording down if it turns out. I've not recorded one of these before. I'll post the recording. Marcus, if you have any materials that you want to post, just send them to me or send me a link. And I'm not by any stretch saying don't keep asking Marcus questions, though I'm sure he'd like to get home to his kids at some point. But I know that they kind of want us to let them go home too. So thanks everyone, and thanks for those who attended remotely. For those remote, I will get better at this simulcasting thing. It's only the second time I've tried this. We're still working the kinks out of it, but I like the idea of providing it, so we'll keep trying it. Thanks.
Aren't they implementing